So in today's lecture, we will discuss about the engine crankshaft angular position. The crankshaft angular position is often termed the engine angular position or simply the engine position. The sensor for measuring crankshaft angular position can also be used to calculate the instantaneous angular speed. As we know that angular speed is the rate of change of the angular position, so simultaneously any of the parameter can be calculated with the help of this sensor. It is highly desirable that this measurement be made without any mechanical contact with the rotating shaft, because we all know that the crankshaft is rotating at a very high RPM, and if we use a mechanical contact based sensor, then a lot of friction, wear and tear will produce, and it can bring down the sensor. That's why for such type of measurement we require a contactless based sensor. Such non-contacting measurements of any rotating shafts can be made in a variety of ways, but the most common phenomena which we use in the field of automotive electronics is either the magnetic phenomena or the optical phenomena. Magnetic use the magnetic field, and optical phenomena use the waves in light rays. Magnetic means of such measurements are generally preferred in engine applications since they are unaffected by the oil, dirt or other contaminants. As inside the vehicle chassis, as you will see that there are a lot many components inside nearby the engine block, and they are affected by the oil, dirt and other contaminants. So that's why when we install sensor, we need to take care that sensor should work on such technology that it remain unaffected by those contaminants. So that's why we generally prefer the magnetic means in case of the engine application. So here we have one of the diagram which gives you illustration of the crankshaft angular position representation. Here a flywheel is there, and on the flywheel we have considered a flywheel mark, and this mark is making a crankshaft angular position from the horizontal center line. This is also known as the reference line. This is the axis of rotation, and it shows that rotation is taking place in an anti-clockwise direction, and this is the complete engine block. On the rear wheel of the crankshaft is a large circular steel disc called the flywheel that is connected to and rotates with the crankshaft. A point on flywheel is denoted as the flywheel mark. Our reference line is taken to be line through the crankshaft axis of rotation and a point B on the engine block. The crankshaft angular position is the angle between the reference line and the line through the axis and the flywheel mark. Imagine that the flywheel is rotated so that the mark is directly on the reference line. This is an angular position of 0 degrees. For our purpose, we assume that this angular position corresponds to the number 1 cylinder at TDC. As in the vehicles, there can be various number of cylinder, either 4 or 6. So when the angular position is at 0 degree, that means when the flywheel mark is on the reference line, that time we are considering that the number 1 cylinder is at TDC, or either intake or power stroke is considered. As the crankshaft rotates, this angle increases from 0 to 360 degree in one revolution. However, we know that one engine cycle from the intake through exhaust require 2 complete revolution of the crankshaft. That is, one complete engine cycle corresponds to the crankshaft angular position going from 0 degree to 720 degree. During each cycle, it is important to measure the crankshaft position relative to the reference for each cycle in each cylinder. This information is used by the electronic engine controller to set ignition timing, and in most cases to set fuel injector pulse timing. So that is all about the working of electronic electronic engine controller, with the help of the crankshaft angular position sensor, it takes input of that information, that what is the angle measured, and based on that it calibrates that what kind of cycle is going on in the various cylinders, and based on that it gives output to the ignition timing and the fuel injectors. In automobiles with electronic engine control systems, angular position theta e can be sensed on the crankshaft directly or on the camshaft. We need to recall that the piston drives the crankshaft directly while the valves are driven by the camshaft. But we all are aware that there is a difference in the revolution of the crankshaft and the camshaft. The camshaft is driven from the crankshaft through a 1:2 reduction drive chain, which can be gears, belt, or chain. The meaning is that when camshaft is taking one revolution, the crankshaft undergoes the two. So that means 1:2 reduction we generally consider. Therefore, the camshaft rotational speed is 1/2 that of the crankshaft. So the camshaft angular position goes from 0 to 360 degree. As in the previous slide we discussed that the crankshaft rotation goes from 0 to 720 degree, but here it clearly mentioned that camshaft angular position goes from 0 to 360 degree for one complete engine cycle. Either of these sensing locations can be used in electronic control system. So we can take a necessary measurement of either crankshaft or camshaft. But the crankshaft location is potentially superior for accuracy, because in case of camshaft drive there are many associated errors that can be torsional error or the gear backlash error. Now in the next lecture we will start with the temperature sensor used in automobiles.